working on this bridge for months. I think I finally calculated it to right measurements. If all my calculations are correct, this bridge should withstand any amount of weight. I don't know what could have possibly went wrong. Everything was perfect. I had everything set up. It was completely ingenious. My whole plan was just perfect. Car here, bridge, goes through. I did it. Would have been so much easier. Don't know what's wrong.
I know what went wrong, and I know how to help you out. What you need, my friend? Some good old linear algebra. Alright, now, see my friend? Oh man. From what I can tell is that you had a truss bridge, which is a bridge made of elements making a triangular unit. And as you can see, the beam going down then forms a 45, 45, and 90 degree triangle. And from that, I guess I can help you out. By putting this into scale, I can explain to you better where you went wrong or how this bridge has to work. So what we have is 1, 2, 3, and 4 joints, and made up of 1, 2, 3, 4, and 5 beams. Now, what we need to do in this step is use Newton's second law to figure out the forces acting on each beam. And Newton's second law is force equals ma, which is mass times acceleration. But since this is a bridge, you want it to not be moving, so acceleration has to be 0. Therefore, the sum of all the forces acting on each beam has to be equal to 0. Otherwise, you're gonna have an unstable bridge and it's gonna collapse, or other things are gonna happen, and you don't want that. Alright, so let's assume that there's a car going by it and it weighs 10 tons. Now, you can use the information to figure out the forces acting on each beam. And by doing that, you have to break each beam into X and Y components. And once we do that, we then have 5 equations with 5 unknowns, all equal to 0. Now, the next step is going to be moving into linear algebra. So now, we take our 5 equations that we got from the first step and put them all into a matrix. It's going to be a 5 by 6 matrix made up of 5 equations with 5 unknowns. In order to solve for each of the forces acting on each beam, we need to row reduce the matrix using Gauss-Jordan elimination. Once you do that, we have these results. The force acting on beam A is negative 7.07. The force acting on beam B is 5. The force acting on beam C is 10, which is our weakest point because that's where our car is located at. Then we got the force acting on beam D is negative 5, and we got the force acting on beam D is negative 7.07 as well. Now, you say, okay, now what can we do with these forces? Well, now we can use these forces combined with the factor of safety to find what type of material you should use in order for your bridge to not collapse or have a limit on the weight. And the factor of safety is simply the strength of the material over the internal force, which should be the weakest point on the bridge. So let's say, we have a car of 10 tons, and our desired ratio of strength to internal force is usually 1.6 because that's the safest, or greater as well. So your material should be able to hold 16 tons then if you want a result of 1.6 or better. And it seems like your material that you use for your bridge will not hold 16 tons. And that's why your bridge didn't work. For a bridge of this size and this material, you need a car of this size to make it work. Look at that. Perfect. Algebra. I can help you solve so many problems.